Hi guys, so today I'm going to be doing a fast, quick-paced episode on logarithms, the inverses of exponents. So just to start us off here, I'm going to give you guys a very simple equation with a little translation. And of course you might be new to this, you might not. So let's see how far you can kind of follow me along with this. So we have f of x equals log 2 x plus 1. Very straightforward, very simple, right? First off, we're going to kind of find the original as in log 2x equals y. So that's the base of this whole function. So we're just going to solve for that, and then we're going to apply the translations, which the translation is the tricky part. But, of course, just remember the key things I am just about to show you. So x, y, we have our x and y. We're going to solve for this very simple parts. We all already know that with such a basic equation, if we have 2 to the power of blank equals something, it is going to equal, of course, 2 to the power of 0 equals 1. And since, as you can see here, log bx equals y, x equals b to the power of y, of course. So that's why we're following along with that. That will make sense, right? So we're going to follow off with that same pattern. I don't think I have to show you guys, but just in case, I'll give you guys another example of 2 to the power of 1 equals 2, right? So we're going to here that one. Okay. Now you can see how it's going to slowly start to increase, exponentially grow, actually. The opposite, I guess. So we have 4, and then we have 2, and then we're going to have 8 and 3. We're actually going to plot these points to get the basic down. So this is the equation we have. It almost looks like a parabola. So having this, what we're going to do next is actually do the opposite operation that is shown. So when we have something that's interacting with x or impacting x, in translation to be precise, we are actually going to do the opposite operation than what you see here. So instead of adding 1, what are we going to do? Of course it's subtract 1. So we're actually going to be subtracting 1 from this original thing. So I'm actually going to change my colors to show the significance. So we have x prime, y prime, excuse me for erasing this. So we have x, y, and y prime. We're actually going to subtract. We're going to keep the y the same, of course, because the y is not being impacted. So we're just going to write the same y's. We're just going to change the x's. So the x's are now going to be subtracted by 1. So we're actually going to have 0, 0 here. Very simple difference, but it's going to definitely impact what we see in the pattern on the graph. So 2 minus 1, of course, equals 1. 4 minus 1 equals 3. 8 minus 1 equals 7. So now we have this kind of pattern. So 0, 0. We're going to start that in blue. 1, 1. Now we have excuse me, 3, 2, and we're going to have 7, 3. You can almost see how it grew. Even though the y's did stay the same, the pattern started to be enacted sooner, because now we are starting at closer to the origin. We now have a greater advantage, a greater jump. That's why it looks like it's larger, even though it truly isn't. It's just the pattern is being enacted earlier. So we can actually see right here, if you wanted to demonstrate how you know that the x was translated, we can actually see from a common point. If we were to write the origin right here, right where our original point is, we can see that it was moved back 1. And that is where this aspect comes into play. It now is moved backwards 1 to find that new point 0, 0, where it is on the origin, the x-intercept, as you will. So that is our point right here. That's how we know we can prove that it's going back 1. But everything else is remaining the same, just to prove that pattern. So it's a very quick example, but if we wanted to do another, such as adding a 2 to the back of this. So now, what is being impacted is the y. The y is now being multiplied by 2. And actually, I'll go with an easier. Well, I should probably write that better, huh? Excuse me. Alright, that's a little bit better. Writing it in front is a little easier to understand. So we're actually going to keep the x x, of course, in this equation is going to remain the same as it was here. But now the overall y is going to be changed. So, we're just going to multiply the y that we had previously, which we have plotted, thankfully. We're just going to keep that the same. So it's also going to be 0, 0, because, 0 times 2 does not work. That's just going to end up being 0. So we also have 1 to 1. So we're actually going to change that to a 1 to 2. We're going to change that 2 to a 3, 2, or 2, 2. That's a 3, 2. Yes, that's a 3, 2, yes. So that's going to be 4. And then we're going to take the 7, 3. Right? That's supposed to be 7, 3. Oops. Yes, that's supposed to be 7, 3. We're going to take that, 7, 3, and we're going to multiply that by 2 as well, so it's going to equal 6. So now we have 7, 6. Yes, that worked. 7, 6, we're going to have 3, 4, 2, 1, 2, and a 0, 0. So it's actually going to jump like this, based on what was multiplied here. Even though the x's did change, it still applied that same change to the y overall. So we can keep that change in x, but we're also going to have to multiply that by 2. So that's reflected in here. So we have the first example where it's very much clear that this was just added, but the original example of log 2 in parentheses x plus 1, we show that, we move that back because it's actually subtracting 1. And then right here, when we multiply that, we got to keep our changes to the x, apply those same changes, but also multiply that for the y to get times 2. So it's a stretch of 2. So it's being stretched by a factor of 2, and we can see those changes in there, right? They are being multiplied by 2, while this is actually being subtracted by 1. I hope you guys learned a little bit from this lesson, this really quick, fast-paced lesson. Keep in mind that this is definitely something to remember and will help you on everything related to logarithms, because once again, logarithms are the inverse of exponential functions. And that is all that I want to show you guys today, just a quick example, not only for myself to remember for my next upcoming test, but for you guys as well in case you guys had any questions. I hope this isn't too messy, and I hope you guys can understand where I'm going with this. Thank you.